Hey, I have a second channel. Cube Compium TDX.
Hey everybody, so when you look at this device right here, you're probably thinking, oh, it's a computer power supply. I mean, it's an atypical power supply chassis, for at least for a computer power supply, but it may not be what you think it is. This is actually not a computer PSU. This is actually a power supply unit for a giant HP printer. So this came out of an older HP printer, a massive thing. I wish I had gotten pictures of it before it was torn apart. It was actually from my place of work. It's like a giant HP inkjet plotter printer, big guy. So if you look at the back here, I'll show you the spec label here in a minute. You look at the back, and then you can tell right away it's not a computer power supply. You got one 20-pin connector here. We're not going to call this an ATX connector because that's not what it is. It's just a 20-pin connector. And we have a power switch. Now the funny thing is this switch does not latch into a locked position. It's like the power button on the front of a modern computer. It's normally open. When you press the button it closes, and you release it opens back up. There's also an LED there. Now I have not actually tested this unit. I'm sure it works. As far as I know, the printer was it would turn on and do stuff. It was just, I think there was something going on with it. It was really old, and I think it was just to the point where they decided it was best to just chunk it. So here to look at the spec label, and right away you'll notice some different things about this unit. So this unit does not have a minus 12 volt rail. It does not have minus 5 volt rail, which older power supplies for computers generally had. Does not have a plus 5 volt standby. It just has 32 volts, 12 volts, 5 volts, and I assume that's 3.3 volts. It's 3V3. But so 32 volts, 3.7 amps max, 12 volts at just 0.45 amps. Yeah, only half an amp on the plus 12 volt rail. Plus 5 volt rail has 1.7 amps maximum available, 3.3, 8 amps. So this thing it's more, I guess you could say on the current side of things, it's more 3.3 volt heavy. Now the bulk of its power, I would say, is up at the 32 volt rail. Yeah, this unit can deliver 118.4 watts just on the 32 volt rail. So yeah, the majority of the power on this unit goes to the 32 volt rail, which the 32 volt rail is used to run the motors and stuff like that. The motors for like the feed the paper, to run the print head back and forth, among other things. I do have a few motors out of that printer. Not sure what I've done with them, but they're pretty good size. They're down here. So, for example, that's one of the motors right there. This is the one that drove the print carriage, the print head carriage back and forth. So a belt would go here. And this is, yeah, very, very massive motor. 32 volts. This one, right here, would drive the paper feed. So of course it went into a little gearbox, and on the back it has just a little encoder, which of course tells the controls, the rotation, speed of the motor, all that good stuff. Also got this motor right here, which I believe is also a 32 volt motor. This one I think this one drove the ink delivery system. So this thing had 4 different like ink chambers for the different colors, and it used like a pumping mechanism to, of course, pump the ink to the print head. We have, see, this is a stepper motor here. Don't remember for sure what this came from in the printer, but I believe this didn't run on the 32 volt rail. This probably ran on maybe the 3.3 or 5 volts, maybe the 12 volt, not sure. So again, that's a stepper motor. And of course, we have this fan, which pretty self-explanatory, 12 volts. Now, of course, there are some fans out there that run on 24 volts. Yep. So yeah, the 32 volts was to feed those big motors. And the crazy thing is, a lot of desktop printers these days, like for example, the HP OfficeJet, like 8610, for example, or the Kodak ESP C300 series. It's a couple printers I have kicking around here. They have 32 volt motors in them, so it seems to be a pretty common voltage for printers nowadays. Printers, it seems, like desktop printers, for example, they seem to used to utilize stepper motors a lot more, but now they've sort of switched over to using brushed DC motors with a encoder on the encoder attached to the shaft to register rotations. Anyways, let's go and have a look inside this thing. So, first and foremost, the total max output power on this unit is 130 watts. That's all the rails combined together. So, trying to get an idea of the age of this unit, I want to say maybe by this date code, I'm going to say the 50th week of 2006, perhaps. Like I said, I wasn't exactly sure how old this plotter or printer was. I was going to guess between the late 90s and early to mid 2000s. So 2006 is kind of on the new end of that spectrum, but hey, yeah. So 130 watts rated max output. This thing is a tank. I mean, it's a tank. So, for example, I could grab this this Astec 250 watt unit out of a HP system, and now, of course, I have a scale on here, but this unit here definitely feels heavier. So, this 130 watt unit is definitely heavier than this 250 watt unit, and this is a unit here that can generally put out its rated 250 watts. Although Astec gets a lot of flack for, of course, the dreaded E-Machines model, the 250-12E. I think Johnny Guru actually tested one of those units, and even though the 5 volt standby was misbehaving, he was able to pull the rated 250 watts out of the unit. So, the fact that this unit is heavier than that 250 watt unit definitely says something. I mean, this thing is a tank. And we're about to actually open it up here. So, just going to take the screws out and have a look inside. Okay, let's see if that's all we need to take the cover off. Yep. Okay, so off it comes. So, you look inside this unit, And it's definitely laid out a bit different than your typical like ATX supply. So this unit, I believe, is like an ATX supply. It is powered at all times. That there's power going into this socket. Now, I know a lot of my viewers probably are not old enough to remember the days of AT power supplies, but before ATX, AT power supplies, they were not powered on at all times. The power button on the front of the computer, as you heard me talking about this power switch, how I mentioned it doesn't latch in, it's normally open, and it doesn't latch in. AT power supplies on really old computers, you would actually reach around to the back of the system to switch on the computer, and you were basically switching on mains power to the power supply. And in newer AT power supplies from computers from the early to mid 90s, when you press a power button on the front of the PC, that power button was actually you was actually activating a switch that was fed with mains power. So mains power would actually go into the system through its own cable that was attached to the power supply, and you would, of course, bolt this switch into the case. And it was a switch that you would press and it would latch, and you press it again and it would unlatch, basically feeding power to your power supply, which would in turn power your system. So this unit, I believe, is a soft on, soft off type. It's powered at all times, and through this switch here, it may actually operate more like an AT supply in a way. But so one of the big reasons why this unit is so heavy is this coil right here that looks like a transformer. It's a series coil, I believe, and it's for power factor correction, passive PFC. And of course, later on these days we have active power factor correction, which is a bit different. So power comes in through here, goes into the EMI filtering stage. You got a couple of caps there. You got a coil there, a couple of Y-class capacitors there. I believe those are ceramics. You got a inrush current limiter right there. I think could be inrush current limiter, or it could be a MOV. Actually, no, the MOVs are down here in this other area. So, and of course, this unit's been unplugged for quite some time. Got your PFC coil there. Got a rectifying bridge tucked in right there. Got what I believe are two MOVs here. Got these two electrolytic capacitors. They're 680 microfarads each. They're in series, so your capacitance gets cut in half. And it looks like we have, I want to say these are bleeder resistors. I can't be 100% certain on that. And it looks like they've gotten a little warm. I'll get you a better view. And if you look at there, you may be able to see a little bit of discoloration around the resistors there. So we continue on forward here. Looks like this may be, I think, what's called a single transistor forward. You got one big transistor right there for switching, and it looks like we have a second transistor for feeding what will be the equivalent of a 5-volt standby rail. This unit, as mentioned, it's kind of like an ATX. It's kind of like an ATX supply. It does in fact have a sleep function, and of course that secondary supply in there would feed the presumably 5 volts to run that. And it looks like this thing, I don't see a plus 5 volt standby noted on here, but we do in fact have a purple wire in there, which will be plus 5 volt standby on a regular computer power supply. And we've also got a green and black wire here, so that could perhaps function as a power supply on switch. The gray could the gray could also function as a power on. or is it certain? I'm pretty certain that the yellow there is our plus 12. The orange is probably our plus 3.3. The blue may be our 32 volts. Black is ground. Not sure about the white. But yeah, so we continue on here. There's our main transformer there. Pretty good sized transformer. We continue on to the rectification stage. And we've got, let's see here, we've got a little coil inside there. Got these massive 50 volt 2200 microfarad capacitors there. And what I'll do is I'll take the camera off the tripod and get you another look. You know, we got other various caps for the other voltages. So let's go ahead and get you a better look at this thing. Okay, so here's a better look at things. So again, we'll start with where the AC power comes in. You got your EMI filtering stage there with your caps and your coil. Got your PFC coil there. Rectifier bridge there. Go around. MOVs there for surge protection. Got these two massive 680 microfarad caps. Again, they're in series, generally. And again, those resistors there. I want to say it's hard to really tell those colors, but it looks like it could be 5.6K or 56K if that's a red or orange, that third band reading from the right toward the left. It looks like it's green, blue, red, gold. I would think 5.6K, you would definitely be putting off some heat with close to 400 volts in this area, I do think. And you guys, the way this works is this unit don't have the switch, so it probably has a built-in voltage doubler circuit that takes in your roughly 170 volts rectified DC coming in from over here. Of course, that's past the bridge rectifier. It employs a voltage doubler, so you get quite a punch there, and that's why power supplies can be very hazardous working if you're not careful. Is because, I mean, we're talking about high voltage DC in this area. It could be deadly. But anyway, continue on. So I want to say that's a single transistor Ford. I don't see a capacitor. I don't see a dip capacitor back here, so I don't think it's half bridge. You got another little transistor down in there, which I believe is your auxiliary power supply. And it probably feeds this little add-on board there. There's another look at that add-on board there. There's your main transformer. There's your secondary rectification there. Coil. And of course those big capacitors there for the 32 volt rail. 50 volt, 2100 microfarad capacitors. And again, various caps for the other rails. Got this other add-on board here. I want to say this add-on board has like the supervisory chip and stuff like that that monitors the unit. Probably also got a fan speed controller on there because, of course, we got our fan plugged into there. And it's funny to note, this fan, it actually blows into the unit. And of course, most power supplies out there, at least for computer power supplies, the fan draws in air to the vents and it exhausts it out the back. Well, this one pulls in air from the back and exhausts it into the printer. That's because this unit sits in a little compartment that has like the motherboard and stuff like that. And I believe, yeah, this fan right there was also in that compartment. So that fan and the power supply fan were the two fans that drew air through the unit, or the whole compartment. So yeah, guys, not your everyday power supply, but I want to say this thing's a pretty big tank. I do like opening up units like this to share, because yeah, these things are built pretty well, I must say. So I'm gonna put the cover back on this thing, and that wraps up for this video. Hope y'all enjoyed it. Thanks for watching.
Well, everybody, that wraps it up for this video, and I hope you enjoyed it. If you did, please like the video. Also, don't forget to subscribe to Computer Channel, and be sure to tick that bell so you'll get notified when new videos are posted. Also, don't forget, I have a whole lot of other interesting videos here on the channel to check out. And also, in addition, I have a second channel, CubeComp MTDX, where I have all sorts of other videos not exactly related to technology. Links to the channels are available at the end of this video. Again, I thank you for your support and thanks for watching this video.